Today, we will be presenting Phase 8 of our Baja SAE project. The group members are Gadiel Coron Ortiz, Antonio Peña Torres, Heriberto Coto Morales, and José Borges Burgos. Outline. During the presentation, we'll be discussing technology assessment, trade studies, project mission architecture and interfaces, and budget. And for each subsystem, owner, study subsystem, subsystem risk assessment, and project plan. These are the review of the literature in which we use 5.
Tokoto, and I will be talking about the trade study, specifically the Conops diagram for suspension. First, we got the double A-arm suspension that have a cost of $2,600, a weight of 5.82 kilograms, and have a high safety, strength, durability, and a medium travel. The McPherson suspension have a cost of $2,000, a weight of 4.08 kilograms, medium strength, safety, durability, with low travel. And last, we have the extended A-arm suspension that have a cost of $3,200, a weight of 7.71 kilograms, and have a high strength, safety, durability, and travel. Now, we have the POC matrix that is a comparison of the three mentioned suspension systems. We have in the diagram we got the cost, weight, strength, safety, and durability, and travel. The weight for each one of those, and as a result, we got that the double A-arm suspension have the highest value, 42. The McPherson have a value of 14, and the extended A-arms have a value of 28.
Good afternoon. My name is Jose Borges, and today I will be presenting our team's project mission architecture and interfaces, and also the N-square diagram for our system. Our project is based on designing and assemble a SAE mini Baja vehicle. This will be our main system, but our project will be directed in analyzing 5 of the main subsystems. These subsystems are the chassis, which will be constructed by my teammate Gadiel Colon, the suspension and steering, which will be analyzed by Heriberto Coto, the powertrain subsystem, which will be analyzed by Anthony Peña, and the brake system, which will be analyzed by Jose Borges. What we can see here in the N-square diagram, this is a diagram in the shape of a matrix, and the main purpose is to represent the physical and functional interfaces between the whole system elements or subsystems. In this case, we have our 5 subsystems, which are chassis, suspension, powertrain, steering, and brakes. The chassis is the subsystem that will provide mounting to each of the other 4 subsystems. That's why it will act as input in each of them. The distance of rear axle has an output on the suspension and an input on the powertrain, because the position of the powertrain must be one of the considerations to suspension position and initial design. The steering curve ratio also has an output on the suspension and an input on the steering. That's because when the system is assembled, we will be able to calculate the angle of the wheel when the vehicle is doing a 360-degree turn. Brakes have an effective pacing input on the steering and suspension, because those 3 subsystems will be assembled close to each other. Brakes also have an effective braking input on the powertrain, because the brakes must be designed in order to be able to stop the car full speed that is generated in the powertrain. The steering have an input of degrees of freedom on the suspension, because the steering needs to move completely without being interfered by the suspension. The powertrain have an output and an input on the chassis because the chassis must be able to support the weight of the powertrain under the racing condition. The suspension have an output and an input on the chassis because it must be able to support the force generated by the floor impact and spring force without breaking or losing apart. Now, I will leave you with my teammate Anthony Peña, who will be speaking about the budget of the construction of the vehicle. Thank you.
Hello, my name is Anthony Peña. I present the budget for SAE Baja. This project estimate costs the structural pipes of cross-molding and the chassis welding is the price of 3,000 2,000. The lump sum, the unique lump sum is the full job and work in this structural chassis and welding. The suspension system is 5,000. The motor is 700. Powertrain system 3,000. The brake system 1,000. The steering system 500. The wheels, the 4 wheels is 1,600. Tools for work in the SAE Baja 500. Electric system 500. Miscellaneous 2,500. The total estimate for this Baja construction is 20,300. This is the total estimate.
Of the subsystem of suspension. The requirements for suspensions without the MOPs, that the number 1 is the ride height must be over 10 inches. The bolt must have a safety factor of 1.5. A minimum travel strut must be over 3 inches. Must pass the SAE suspension test that consists of 5 feet drop. A wheelbase must be no more than 68 inches. Now we have the risk assessment. The first one is that we have an unstable suspension, a bending due to impact, failure in joints and bolts, and withstand maximum loads. The mitigation for those risks are a robust design to absorb vertical travel as well as compression for absorption. Selecting material with a big range in the elastic region and a high yield strength. Use components that comply with regulations and are made of resistant materials. And selecting the appropriate engineering material that can withstand vertical loads. And now we have the project plan for the suspension. Now my partner will continue with the presentation. Thanks.
I am the owner of the chassis subsystem, and I will be discussing the MOPs, risk, how we can mitigate them, and the project plan. This MOP list are just some of the requirements of the chassis design and construction. These are: the roll cage must be 60 inches wide, must withstand a fall from a height of 6 feet and roll of 30 degrees. Secondary members minimum wall thickness of 0.035 inches and minimum outside diameter of 1 inch. Straight members may not longer than 40 inches. Bend members may not have a bend greater than 30 degrees. Frame must weigh less than 130 pounds. People between 5 feet and 2 inches to 6 feet and 4 inches tall and 100 30 pounds to 250 pounds in weight. Some of the most important risks for this subsystem are adaptation for all subsystems, chassis specification according with 2022 rules, and unacceptable slip in drill holes, material failure, drop front, rear, and rollover impact. In the Sophia diagram, the probabilities and impacts were established according to the analysis of each risk. The letter A have an impact of 4 and a probability of 2. The letter B have an impact of 5 and a probability of 1. The letter C have an impact of 4 and a probability of 1. The letter D have an impact of 5 and a probability of 2. The letter I have an impact of 5 and a probability of 3. We can mitigate this risk in the following way. Another subsystem needs communication to maintain design constraint. To design a chassis, it's necessary to follow the SAE rules. Sleeves must extend beyond the tube. To select a material is need a numerical evaluation to select the correct material. The chassis design needs to consider the driver's safety. This will be the project plan for the chassis subsystem. We'll be finished phase B in week 3 on October 20. And we will finish phase C1 for week 1 on November 17.
Hello, I am Tony again, and I present my subsystem, the powertrain. Powertrain MOPs is the power wire must be at the 10 steel or 6 and 61 T6 aluminum. Drive shaft shall be contained from fouled by 2 drive shaft hubs, weighing 51 mm, all of the 1-3 leg points and the 2-3 length points. The drive shaft hubs shall be a minimum of 25.4 mm or 1 inches wide, meeting the same materials requirement. The powertrain system must be able to be operated with the total height from 1,000 pounds maximum. Okay, this is the rig for this powertrain. You see, any bolt can make the powertrain free from the engine and the chassis. This probability is high and the impact is very high. Powertrain parts can break and make it damage the pilot, truck, or vehicle. Probability is medium and impact is medium. The powertrain system can reach high head temperature, and this can lead to failure. This probability is low and the impact is medium. Leakage of the transmission fluid and lubricants, the impact is medium and the probability is low. For these risks, the mitigation is the planning of mitigation is usable, which complete with regulation and made of resistant material. The component of the powertrain must be protected and covered. The wires contain ventilation ports along the path of the wire. The transmission box must be a closed system. The powertrain planning in the phase B is this. the phase C, C1.1, the interface diagram in the week 3. I'm working in this. Detailed analysis in the week 3 and week 4. In the break, design to a specification and drawings. And the verification system and project plan. This work in the break. Okay, in the phase B, I work subsystem architecture into week 4 in September. 3 study for critical component in October, week 1 and week 2. Subsystem risk assessment week 1 and week 2 in October. And project planning in the week 3 in October. And the final presentation is today.
Good afternoon. My name is Jose Borges, and I will be defining the brake subsystem. This system has some specifications that will measure the performance of the brakes, which are listed below. The first measure of performance is that the primary hydraulic system shall act on the 4 wheels of the vehicle with a single foot pedal. A half-inch cylinder shall be operated directly by the pedal. The disc will be 8 inches in diameter and must be able to lock all wheels in rough conditions. The components of the braking system shall be made of steel or aluminum and shall be withstand a force of 450 pounds or 2,000 newtons. The 1/4 of an inch lines shall be placed securely and shall not interfere with the other components. The material of the line should withstand the pressure created and compatible with the brake fluid used. We can see here a SOFIA diagram with some of the risks that we can experiment on the braking system, which are hydraulic line leakage or in the reservoir, the calipers not able to stop the speed of the car, the disc or rotor overheating, pedal deformation, and brake lines pinched by sharp edges or another subsystem. We can see the probability of occurrence and the impact of occurrence, and with a legend being low green, medium yellow, and red being high. Here we can see the mitigation strategies for those risks, which are having 2 independent hydraulic circuits. In case of one of them fails, the other one should keep working. Brake lines should be long enough to provide full range of motion. The master cylinder and brake pads should be large enough for the necessary pressure. A temperature distribution test will be conducted on the disc to prevent failure, and a displacement test will be conducted on the pedal to ensure the best metal selection. Here we can see the project planning for the upcoming presentations. We will be presenting the phase B on October 20, and the phase C1, which will be on the first week of classes of the next trimester, and it will be on the 17th of November. Thank you.